Alright, video solution for homework number 7 on question number 4. It says magnetic field of rotating disk. Compute the magnetic field on the axis of a circular ring of radius r carrying current I. The ring is in the xy plane and is centered at the origin. So here we're trying to find the magnetic field at a distance z from the origin where this ring of current I and radius r is centered on the xy plane. So for this one, we can use the Biot-Savart law, which reads B, where B is the magnetic field, equals mu naught times I over 4 pi times the integral of dl cross script r over the magnitude of script r squared. So we take all of these components and we set them up separately. So dl is just going to be the chunk of this, of the loop, which is just going to be the radius times d phi times phi hat. Vector r is going to be zz hat because it points from the origin to the point where we're measuring the magnetic field. R prime is going to be ss hat, which is also just going to be rs hat because s is at a constant r because it goes from the origin to the source point. Script r is just this minus that, which is just going to give you zz hat minus rs hat, and the magnitude of script r is the square root of z squared plus r squared. So the Biot-Savart law reads mu naught times I over 4 pi times the integral, and after plugging in all of these components, it's r d phi phi hat cross the quantity zz hat minus rs hat. And that's all divided by z squared plus r squared quantity to the 3 halves. After doing this and integrating from 0 to 2 pi, you end up with mu naught I r squared over 2 times the quantity z squared plus r squared to the 3 halves, and that's in the z hat direction. Part B, it's the same problem, except instead of a ring, it says it's a CD, which is just a disk, and it tells us that it has the surface charge density sigma. So it first wants to know the surface current density K, where K is equal to sigma times velocity. Velocity, in this case, since it's spinning around, is the angular velocity times r, and that's in the phi hat direction. So K is going to be sigma omega r phi hat. Plugging it in, and then it wants us to use this surface current density to find the magnetic field. So we can use the Biot-Savart law for that as well. It reads mu naught over 4 pi times the integral of the surface current density cross script r over the magnitude of script r squared times the area element. So plugging everything in, you end up with mu naught over 4 pi times the double integral of 2 pi, from 0 to 2 pi, and from 0 to big R because it's still on a radius big R. All of these are the same with the exception that r prime, vector r prime, is s hat because the radius varies, and that affects these accordingly, and the area element is SDS d phi. Plugging that in, you end up with sigma omega times r phi hat cross quantity zz hat minus ss hat over quantity z squared plus s squared to the 3 halves, and that's all times sds d phi. And integrating over these boundaries, you're going to end up with mu naught sigma omega over 2 times big R squared plus 2z squared over the square root of r squared plus z squared, and that's minus 2z, and that's all in the z hat direction. So for this, for part C, it wanted us to plug in certain limits and see what the magnetic field was. So for this first one, limit as r goes to 0, so as r goes to 0, you end up with just the constant out front times 2z minus 2z, which just gives you 0. And that makes sense because as r goes to 0, you end up with no disk at all. So as the disk diminishes, so does the magnetic field. Limit as z goes to infinity, that's also going to give you 0, because as you get an infinite distance away from the disk, the magnetic field is going to grow weaker and weaker and weaker until it turns into nothing at all when z reaches infinity. Limit as omega goes to 0, b is once again going to be 0, because this disk has a surface current density, and the entire disk itself is rotating, and it's that rotation that creates the current and the magnetic field. So if it isn't turning, there is no current, and if there's no current, then you can't have a magnetic field. So that's also going to be 0. And if you plug in 0 for W, then this entire thing is just 0 anyway. And limit as z goes to 0, plugging that in, the magnetic field is just going to be mu naught sigma omega, or 2 times r and the z hat. And that makes sense because as you get inside of this plane, at the very center of this disk, the magnetic field is just going to be constant. So that's my solution.